Yeah, but unfortunately, a lot of them weren't the ones who were standing. It was. Okay, we're ready for our discussion from the groups, and we are running a few minutes late. So instead of being 10 minutes and 5, we're going to do 10 and 4 for the leader, and so that will preserve as much of the large group discussion time as we can at the end. And for the leaders, I'll give you a sign at 2 minutes till the end of your 10. First up, the purple group. The purple, which I think is a vet or a vet's designee. A vet, that's what I figured, yeah. Knowing most of the people in that group, I could see them very handily avoiding any designee status. So.
What's that? Oh.
Don't ask me what. I don't know. I have any idea. I'm not sure. Pointed at that? Oh, okay.
Oh, maybe that was from
the right arrow. The right arrow, yeah. You just had to point it at the computer rather than behind me.
Okay. All right. Okay. Well, thank you very much, Harold. So I'm representing the purple group, which is the physical scientist group. And we had a good active discussion for the whole time. It was quite interesting. We came up with two pages. So this is part 1 of issues and research. So I'll try to explain each bullet a little bit. You'll notice on this page we are kind of organizing things by different ways to reduce false alarms. On the big outbreak days where there are a lot of fatalities, actually the forecasts seem to be quite good on those days. So there may be improvements in the forecasts and warnings to make, but they're already pretty good. So one thing that we think, though, is that maybe we still had a lot of people who died. So perhaps their desensitization to the warnings is a problem because of false alarms on other days. And I'm sure that's an issue that we'll talk more about, and we'd actually like input from social scientists on that. But with that as kind of a backdrop for how we were thinking, one way to do that is just through better understanding of how these storms work, what environments do they form in, and that has several different temporal scales. So, we have both watches that we like to improve and also warnings, and those are very different time scales. One's more of a forecasting time scale, and one is a little more immediate. So when we're looking at watches and that kind of time scale, or even longer, improved understanding and modeling of convection initiation, and that simply means how do you form a storm to begin with. And the processes there are fairly straightforward. If you read the white paper, you saw some discussion of this, but getting that right in the models turns out to be very difficult because they depend on things that are hard to do correctly at the resolutions that we have. And so it's often a tough thing for forecasters to just know whether you might be in between having no storms at all or storms that will be very damaging if they do form. So getting that part right is something that we'd like to improve. The next thing is improved assimilation of observations into forecast models, particularly within the boundary layer. And so those of you not that familiar with numerical modeling, we have a lot of observations from all different sources, and we try to take those and put them into the model. And then our forecasts are based on that. But that's a difficult thing to know to do correctly. It's very easy to do incorrectly. And so better improvements in understanding the best way to do that, especially as we have new types of observations, such as dual pole data and other things that we haven't really been familiar with assimilating. That's something we need to know how to do correctly to improve our forecasts. And we say particularly within the boundary layer. The boundary layer is the lowest part of the atmosphere. And the variations in that layer tend to be the ones that are most important to the storms. So we really need to get that correct, although upper levels are important too. But they're actually a little easier probably to get correct. The next bullet is boundary layer studies of the environment after convective initiation. So this is getting more toward understanding, now you have storms, what are those storms going to do? Are they likely to produce tornadoes? And that's where you need to really know what the environment that they're in looks like and how is it changing in time. And that will affect the potential for producing tornadoes. So studies of what exactly happens to the boundary layer over the course of the day and how that influences tornado formation is something we'd like to study. The next is improved understanding of storm scale processes that distinguish tornadic from non-tornadic mesocyclones, as well as tornado lifetime and intensity. So a mesocyclone is an area of rotation. In this case, it occurs both at mid-levels and at low levels. But you can have a strong area of rotation or a strong mesocyclone and never get it to contract into a tornado. And storms can look very similar up until the time that they do that. So understanding what exactly distinguishes when they're going to do that and when they're not is something that can be really helpful for warning in advance and reducing the false alarms that you have by warning when nothing really is going to happen. And then tornado lifetime and intensity. Knowing factors that establish the tornado lifetime could help you know when you should end your warnings and when things are not. Some storms keep producing and producing and producing. When are they not going to do that, such that we shouldn't warn the next people down the road? The next part is more based on better observational tools to help us reduce false alarms. And one thing that came up a lot was the gap-filling radars. So our radar network right now covers the United States fairly well, but they're, to do that with the number of radars that we have, they end up being fairly far apart. And there are places where there's not coverage. The problem with them being far apart is that the radar beam goes up as it goes out. So the farther away you are, you end up looking at the middle of a storm, which might not be related to what's going on near the ground. So gap-filling radars you could put in between there to really cover the lower levels better, so that we have more sampling in the area that we need to know about in order to say whether tornadoes are happening or not. Profilers are another type of radar that gives us lets us know what the winds, how the winds are changing in the vertical, and this is important to understanding whether storms are likely to make tornadoes. And LIDARs are kind of similar. And one issue here is determining what is the optimal mix of these things. Do we need, how many gap-filling radars do we need? Where would they best be put to have the biggest impact? All those sorts of questions are more research questions before you would even implement an observational strategy. Part two, the first one is better understanding and observations of tornado structure to better inform building codes, etc. So a lot of what we know about how tornadoes look, what the wind field looks like inside of them, is not based on direct observations of them because they're very difficult to get. With a radar, you have to be very close to them. So more observations that are, so what we base it on is either numerical models that might have some limitations, or laboratory-produced tornadoes that may or may not be acting exactly like the ones in nature are. So more close-up observations to tell us that structure would let us know better how buildings would interact with that wind field. And the second part there is a rapid, independent post-event assessment system. So after an event, having a really rapid response to get there before things are taken away and we can no longer tell what really happened. And this would be to determine damage and causes of mortality, similar to what the NTSB does when there is a plane crash. And using multidisciplinary teams to really address all aspects of what happened in the event. So recommendations, in addition to the things I just talked about, which were kind of the recommendations for our part of the field, for some of the other groups, since we kept talking about things that we felt other groups could inform us better about, what do individuals consider to be a false alarm? How far away, if you have a storm occur somewhere, is it a false alarm to you if it didn't actually come to you? And quantify the effects of false alarms. How many people actually do die because of false alarms? That is something our group doesn't know, but we would like to know from other groups. The second, develop a well-calibrated, well-researched, probabilistic hazard system where you don't just have a yes or no, you're in a tornado warning or you're not, but you have a certain probability that a tornado will come near you or will be coming to your location. But how do we effectively communicate that? And that's certainly something that would involve all the different groups to figure out. And then finally, integration of forecasters into scientific discussions by having them attend conferences. And there has been a lot of good interaction that way in the past, but we, I guess, would like to encourage that to continue and maybe even improve and facilitate better training and integration of what we know into the forecasting process. I think Paul did a calculation that it would be less than what a satellite would cost. Yeah. If you were to fill everything. Right. But, so... That was roughly the number I thought we were talking about. So. Others? Mark in the back.
Yeah, well, a big shout out of thanks from the engineering community for making it on your list there. What we really need is, and we were in a different group, is to understand what the characteristics of the wind are at the surface level that interacts with the buildings, which is not just the maximum speeds, what's the gust structure inside there, the directionality, the vertical updrafts, et cetera, as we're finding that has a big effect on the uplift on the roofs. And so observationally, a combination of through experimental vortex simulators, but we've got to get some ground truth verification, whether that's radars or the totable instruments or other kinds of things that we've just got to be able to get that information, because that also then drives the climate data and the tornado climate data that we need to understand, okay, if we're developing design maps for different areas of the country, et cetera, what's the maximum expected tornado wind speeds in the area, so to help understand not only the meteorology of the individual storms, but the tornado climatology.
Right, right.
Well, we'll have group discussion time that things come to mind as we go along. Okay. That may well happen. Next up is Blue People. The Smurfs, yes. And representing the Smurfs. I'm sorry. I'm really sorry. You can blame Chuck. And as we can do for most things. Okay, it's just the right arrow, and your computer's over there that you're pointing at, the Mac Minis.
Okay. So I was with a group of forecasters and weather researchers and so on, and see what we had to say here. So there were a number of issues that we discussed, and some So I'm going to try to hit the highlights on those, and then we'll have some recommendations at the end. So the first bullet you see there is a recognition of difference in warning process, perhaps across regions, and having an understanding of what that process is, including the non-meteorological issues that go into the warning process and impact the warnings that are issued. So the second one has to do with, well, how do we learn what the reasoning is behind problems that we have, like missed events? What are the causes? How important are human factors in those missed events? So not only the science, but the human side of warning decision making. The third one, specificity of warnings. We have a lot of tools that have come to be, that help to provide more specific information, especially in terms of mapping. How do we enhance information given there are things going on in the central region to enhance wording, for example, associated with warning? We need to make sure that that gets well assessed. We learn from that and implement things that went well, and rejudge about other things perhaps that could be done better in the future. There are conflicting sources of information. You may have a siren going off in your area, but there is no specific warning in your area because of the rules that are used, for putting off sirens. Perhaps it's for a large area, but your polygon doesn't cover you. So how can we avoid some of this confusion? Okay. Another thing we discussed is assessing best practices, perhaps in offices, and seeing how, learning from those that could improve warning performance across offices. And then the next one really relates to the warn on forecast issue that is coming to fruition in perhaps in the next 10 years, going from warn on detection to warn on numerical model output and being able to produce probabilities associated with that. Well, the infrastructure to make this happen, is not currently in the National Weather Service. So how do we develop that infrastructure? How do we communicate probability? Do we communicate probability? Do we find perhaps another way to communicate that information? And one example that was brought up is the Torcon concept that's used by the Weather Channel. Paradigm shifts. This one really goes into transitioning between these issues and recommendations we have. Paradigm shifts in the National Weather Service to bring forth things like specific warnings, warn on forecast, concepts. Might we move from individual forecasters being responsible for one thing to teams of forecasters? A new way of working in the office. So here are our recommendations, and one of the large bullet then on the top puts forth that idea of paradigm change. How do we want to accomplish research that redefines rather than repackages the warning system across sectors. And that's a big difference. They're redefining versus repackaging really similar information that has gone out before. So this gets back to the basics, such as investigating what should be warning on. Should all regions have the same things are being warned on? Should they be locally driven? What tools do we need to be able to specify the hazard, not only in terms of detection, but perhaps different parts of the storm, and saying, this part hail, this part tornado, for example, in the area that will be impacted and when. We know that people and technology change over time. How much is that considered in the warning process and how things evolve? I understand that some regions are looking at this issue and others are not, but it's perhaps something that should be a continuous process in which this is being studied and that learning, updating what we do in a definable way. And then also measures of warning accuracy, which Yvette brought up. Are they relevant to the public, the ones that we are using? Are there new measures we should be using that would be more meaningful and perhaps acceptable to the public? And one example that Greg Forbes brought out to make this perhaps, in an example, how far away does a tornado need to be considered a false alarm? What is an acceptable distance? And there are certainly other questions like that that could be posed. Related to that, perhaps I heard that this is going on in some locations, developing an impacts catalog for your region. If we're going to have impact-based warnings, what are the impacts that are locally relevant where the warning's issued? Leveraging social networks for sharing warning information. Perhaps getting something through that could be more meaningful for someone than just directly from the Weather Service office. And this one is more about how do we use our infrastructure in the Weather Service, the employees, to match talent to the warning need, not only during high-end events, but other events as well. And then finally, we wanted to talk about dual polarization because that's coming to a National Weather Service office near you in the near future. So investigating how to best utilize that tool in the National Weather Service. How do we use things like tornado debris signatures in warnings? How do we maximize its utility, not only observationally, but in numerical models? And this last bullet also relates to what Yvette said in terms of having dialogue, and this has started through the Warning Decision Training Branch, doing things like dual polarization, storm analysis, each month, conversations on storms of the month. We talked about a polygon of the month, things like that, so that you have a feedback loop among the sectors, understanding how things are working, what changes and improvements might be needed.
I would argue that I think you also need to look at successful events in order to try to ascertain what differences might exist between a success and a failure. So you shouldn't just look at your failures.
Yeah, that's a good point.
I don't need this bloody mic.
Well, okay. Let me say something. Okay, we are attempting to capture what's said so we can get a transcript. And so so that when we write the report up, we actually know what was said, so we really would appreciate it if you use the microphone. That'll make that a whole lot easier for us.
I'm not sure if this is the right session to bring up this topic, but it's popped up now in the first two talks, the theme being along the lines of communicating what we know better to the public, and I feel like in some cases, we give them unrealistic expectations of what our capabilities can be. For example, to give you a specific example, on March 1st, NASA and NOAA put out a press release about the new GOES satellite. GOES-R was going to increase lead times by 7 minutes for tornado warnings. And there's no basis for that as far as I know, and I'm just wondering how we deal with these things. Maybe this is not right for this session.
I have to say that's something we did not discuss in our group, but it's definitely an issue, and I've seen things like that come down the wire as well, and it causes concern.
A question, you had an item up there about how you define, I think, a near miss, or if it's a blown forecast. And I guess being not in that area, when you've got a warning polygon, isn't it okay? Well, if there was a tornado in that warning polygon, or there wasn't, isn't that just sort of the criteria? Or
that's a meteorological criteria, used by the Weather Service. But is that what you're providing that warning to the public or publics? What is their concept of whether or not, it was a hit or a false alarm? So I think, we have our own rules for how we validate and evaluate how we're doing, but how are those rules relevant to the customer? And I think that's what that gets at.
Thanks. And one of the things I just want to point out along that same line of thought was we talked about with Warren Forecast being an ensemble probabilistic-based system, and as we go down that path, I think the rules will have to change. So the idea of a polygon being either in it or out of it like a brick wall, I think we have to revisit that because we have to look at if you're near it but not exactly in it, you're still under some degree of threat. How do we communicate that, I think, will be an issue.
Big theme from December was test beds when we talked about all this stuff, vetting it all through a test bed before we vet it with real people like what is being done now.
There's not real people in test beds.
There could be.
Thank you, Pam. Green. And I'm trying to think of something really amusing to say about green. But what can we say? Yeah. In fact, we all would like more green.
It's always greener on the other side of the fence.
Ooh, very good, very good. Okay. Here's your little, there's the right arrow, and that's your little computer right there.
This is the right letter?
No, this one.
Ah, okay.
And there's your little computer right there.
Okay, I did my very best not to have to do this, but we are the Preparedness group, and you think my little right arrow is going to do something here, huh? Ah, yes. I tried also not to give this presentation, but I still had to do it. So in terms of preparedness, we really wanted to think about preparedness in a very, very broad kind of way. And one of the things that we consider problematic is we don't really have conceptual and operational definitions of what preparedness and related constructs mean in the context of a lot of hazards, but certainly in the context of tornadoes. Are we thinking of preparedness as building safe rooms? Are we thinking of preparedness as being evacuation? Are we thinking of preparedness about knowing how to evacuate? Are we thinking about preparedness about how to shelter in place? There are many, many kinds of quote-unquote preparedness. Furthermore, it's on many, many levels. We started really with working paper 3, which I wrote, which was basically focused on household preparedness. But we're also concerned about different levels in terms of government preparedness, institutional preparedness such as schools, private business preparedness. Preparedness not just in the household, but preparedness at all levels and across all groups. We're interested in the organizational, and we think much more needs to be done in terms of the organizational and institutional contexts within which preparedness occurs. So, for example, where does the preparedness happen? How do federal agencies communicate with state agencies and in turn to local agencies, to private enterprise, to households, to schools? There's a huge range of occupational and institutional or organizational and institutional kinds of networks within that impinge upon, help to determine and receive information on preparedness. Probabilistic, multidisciplinary, and I want to really emphasize multidisciplinary risk analysis of high impact, life-threatening weather. And we include not just tornadoes in this, we're also thinking about flash floods, hurricanes, droughts. We tend to take an all-hazard perspective here because tornadoes, in a sense, are sort of in between earthquakes that have no warnings at this point in time, although some of my colleagues in California think we have warnings, to hurricanes. We have a fairly long lead time at this point in time. So there's aspects of both of them when you talk about tornadoes. How do we do a full assessment of forecasts and warnings and the response process? What is the potential for preparedness to actually reduce risk? and what are the different kinds of risks that we're trying to reduce here. We made reference to the fact that there's a National Research Council report that came out in 2010, which is called When Weather Matters Most. We recommend that be something that should be considered or referenced. And it's not the only report out there. There are a lot of reports that address some of these issues that have been done in other agencies and in other settings that can be very useful in this context. Yep. Okay. Helps if you do the right arrow. Oops, I went too far. Okay, we're also concerned about the inclusion of different population segments as input into research and program design. In other words, instead of being a top-down, NOAA talks to the other federal agencies, et cetera, down the line, we need to find out what the people out there that are receiving these things, what it is they want to receive, what they can use, how they use it, how they've used it in the past, and bring them into the planning process. If we don't know what is influencing people or what they can use, we're not going to be very successful in getting any messages out. So we really urge a much broader attention being paid to who the various audiences are and actually engaging them actively in the research process. We recognize that there's a continuum of preparedness research needs, and a couple of the other groups touched on this, but there's a continuum of things across geography, across population segments. In other words, some groups don't have access to things like the internet, so if we want to do things on the internet, we've got to worry about those people that can't do it, people who cannot hear radio, but can maybe get sign language. How are you going to get it to them? And there's all kinds of disabled and aging and other kinds of groups out there that, one size does not fit all for how we disseminate information to them and how we expect them to hear it. What is needed to respond? And here we sort of just looked at some things that we think you have to have if you're going to be able to respond to something and prepare for it. Information about the hazard itself, protective actions that are possible, physical and social resources needed to receive a forecast or warning, how we interpret environmental cues and how different people interpret them, and how we make informed decisions about appropriate protective actions in these different contexts in which we live and work. And then lastly, in terms of research gaps, what are the metrics of success and evaluation that we're going to talk about? It's not limited to injuries and death. As someone who's done research in the area of injuries and death, I can tell you that injuries and death are pretty fuzzy concepts, and this is somebody who's talking from a public health perspective. There are lots of other things here, which are property losses, damage to public buildings like schools, county courthouses, private business. There's many, many other kinds of outputs that we need to be concerned about beyond injuries and death. I realize that NOAA has been charged by Congress. That's what they're supposed to be reducing. But there's a lot out there that I think you're missing. You're throwing out the baby with the bathwater in a way. And then our big recommendation, we called it a Directorate of Human Dimensions of Weather. We think there should be some kind of a federal national lab for interdisciplinary research that would draw on all of physical and natural sciences and social sciences. And as part of that, we want to emphasize that there are many, many, many different kinds of social science. There's political science, there's economics, there's sociology, there's communications, there's psychology, there's geography. And we all do different things, and within each of those disciplines, we do different things. And in the group that met today, one of the first things we did was go around the room and, what do I do? Where do I come from? What kinds of aspects of social science research, quote unquote, am I involved in? You know, having one social scientist involved in something, there is absolutely no way in hell, ladies and gentlemen, that one social scientist can represent the range of research and burgeoning ideas that are in not only the hazard literature, but in the social science literature. And so it's not a matter of just at the last minute finding one social scientist and having them come on board to somehow make you feel like you're doing good. So I'll stop there.
The guy with the hat in the front row.
But give him a mic so that he's on board.
Yeah, so that we can't deny.
Really good presentation, and thank you for providing it, many stimulating things. But there's one topic I want to take a little bit of issue with, and that is that you made the statement that we shouldn't expect a system to be effective if we haven't accounted for the specific needs of the people that we're trying to serve. And I think I have to point out that we have a track record of decades of decreasing fatality rates from tornadoes by a system that heretofore has basically ignored the needs and interests of the potential users. So we have a system that's worked remarkably well, and I'm pretty confident has saved thousands of lives. We've reached a point now where it appears to be bottoming out, and I think what we're really identifying is ways to improve upon that, continue to improve upon that performance so that we can continue to see a decline.
Let me just say a term we didn't put up here because it's too much the medical model and out of medicine and public health is the idea of compliance. We don't have any research out there that really tells us in any definitive fashion who has received warnings and how they've used warnings and what they've done, okay? So we don't really know if it's gotten that much better. And that's one of the reasons why I say I think we have to go beyond injuries and deaths, because there is a lot of other things that happen in terms of families being dislocated and things of that sort, and we saw that after Hurricane Katrina.
Thank you, Linda. Like I said, we'll have time at the end for things that may come up that cross the talks. Yellow. Jay. Jay Baker.
Thank you. We were the social scientists talking about individual and household response. And to begin with, we couldn't figure out why it's so hard for y'all just to go ahead and predict the tornadoes more accurately to begin with. It would solve a lot of the problems that we spend a lot of times talking about. But given it the way it is it which one? Oh, on the right. It is. It's not an arrow. It's a dot. Okay. I think that probably, I didn't even notice that there were different headings at the top of these pages until other people started doing their presentation just now. So ours is kind of but it's what I have to say kind of reflects our discussion anyway, because it was fairly free range, and a lot of it was talking about what we think we already know and about policy issues and those sorts of things. So this is going to basically be kind of a mix of things that we think we need more research about, and also ways of approaching the research and methods to use. The issue about false alarms has been mentioned several times, but there are a lot of different ways to measure false alarms, and that's part of what we're saying we need to do. That is, to measure it different ways. Even with some of the new terminology that's been used, that you're using like the certain catastrophic destruction, if that doesn't happen, but you have a tornado, then that's a false alarm in some people's minds, I think, you know. So the idea is to see what effect different types of false alarms have and what the threshold tolerance level is for them. I think we all kind of acknowledge the fact that at some point, if something happens often enough without the expectation not being met, then there'll be a drop-off in response, but we don't know exactly what that would be. And then there are methods of how to assess it, and I'll talk about some of that in a minute. Research implications of response options. This is the idea that not everyone can do the best thing when they're being threatened by a tornado. And so you would think that the kind of forecast accuracy or the kind of wording that's appropriate would vary depending on whether someone has a basement in their house and whether or not there's a safe room in a significant number of houses, or whether there's a proximity of buildings that are known to be safe in the community where people can take refuge, whether people live in mobile homes, and those sorts of things. So all we're saying here is that there needs to be this context. You know, when we start evaluating messages and the adequacy of warnings and so forth, we need to take into account what people ought to be doing to begin with. In addition to that, there's at least the potential for more research on whether people did the right thing. That is, if there's some experts around who can say, given the sort of house that this person had and the type of rooms that they had and the proximity of substantial buildings nearby, ideally, we think they should have done this in response to the warning, whether or not people did that, rather than just our asking them, did they go to the interior part of their house, or did they go to the basement in their house, and so forth. This issue about early alerts means, you know, people don't necessarily just start responding when they hear a siren going off. Typically, there are precursors in terms of weather information for a day in advance or more. And the idea is to start tracking the timeline of response earlier, you know, whether or not people are doing things when they hear that there's a severe thunderstorm watch, or when the local weathercaster simply talks about the likelihood of severe weather in the next couple of days and those sorts of things. So the idea of that kind of creating a background level of concern and how that might affect the final responses that people take. Need for better mortality and morbidity data. We have some epidemiologists working with us who do this kind of research. That is, they try to explain variations in why some people died and why some didn't and why some had severe injuries. And they've talked about how the data that they have to use is not as good as they would like and not as standardized as they would like, and they don't have access to all the data that exists. So the idea is if that line of research is going to be more effective, then there need to be some improvements in the data and so forth too. How do non-weather service sources affect response? This is mainly television, but there are probably lots of others. There are blogs that you can get information about, you know, on smartphones and all sorts of things like that. So the idea is just this, with this abundance of information, how it interacts and results in people taking different sorts of actions. Laboratory simulations and experiments are within the social science context is you try to replicate the kind of information people might receive in a real threat. Maybe different graphics that you try out, or different wording, different instructions. But a lot of these things that we've talked about before could be analyzed this in a controlled experiment. That is, where you're able to manipulate and change the different levels of these things so that if people respond differently in one situation or set of situations in another, you can isolate why, and it's because of a graphic or the wording of the message and so forth. We think we could also do this sort of thing with regard to the false alarm rate, and that is you can put people through a number of different simulations in a game kind of environment and so forth to see whether or not when people have responded and haven't been hit a number of times, whether or not that'll cause a drop-off in response in the future. There's actually been some of that done with hurricanes. Need for cognitive task analysis methods. This is a particular method that one of our members has a special proficiency in, and I'd like to kind of broaden it a bit. You know, most of our surveys about individual level response are pretty canned surveys we have open-ended questions, but we categorize their response pretty briefly. And the argument here is to use more in-depth methods in addition to those that we're already using, where we actually try to explore and understand the actions that the person took and why they made the decisions that they did at different time points and so forth. And this is one technique that's been used very effectively, but the idea is to go beneath the surface more in depth than what we've been doing up to this point. evaluation of need to compare community level differences in policies. This could be in terms of how they use their sirens, whether some systems are more effective than others in terms of causing confusion on the public, on the part of the public, and other sorts of things. And this kind of suggests that there might be some more need for research on how emergency management directors and officials use the forecast information they have at their disposal to decide whether or not to use their sirens or to make other sorts of protective action recommendations to the public. Evaluation of methods for conveying and translating expert threat assessment effectively. This is a very broad one, obviously, but and it kind of encapsulates a number of the specific things that I've seen in some of the other presentations. But it has to do, the general idea is to look at a family of methods that can be used to try to figure out where things are going wrong. That is, experts believe that based on the best indication, we should be having people do certain sorts of things, and clearly we aren't in all cases. So it's really just a matter of looking at all the different steps along the timeline or the process like that, where things might be going wrong, and try to identify where they are. I thought I had one more in here. Maybe I skipped over it about interdisciplinary teams of researchers. And I'm real glad the previous speaker pointed out this notion that although we may all look the same, not all social scientists are the same. So when I say everyone believes in these interdisciplinary teams, we do mean that, but we also possibly mean a mix of social scientists as well in order to try to cover all the bases that we need to cover.
In the back, behind you.
I'd just like to briefly underscore that last comment. When I looked at the description of this meeting and the results from the Norman meeting and saw the bullet lists of challenge questions and research issues and needs and so on, I looked at it and said, oh, I can do that, and we can do that, and we can do that. Ooh, I can't do that. We need a sociologist for that, even though I'm a, quote, social scientist. Or I can't do that. We need a cognitive anthropologist to do that. I can say this with absolute certainty. Has to have an interdisciplinary mix. Social sciences are not a lump sum. Lots of different skill sets, capabilities, and expertise, and all of those skill sets and capabilities are highly pertinent to the agenda and important issues that are confronted by this group.
Right next to you.
To add on to that as well, don't forget practitioners. You hear engineers and social scientists, but don't forget the practitioners, the local emergency managers that are going to be using a lot of this information.
Good point.
Maybe I missed it, but I think you passed over the issue of defining weather ready.
Yeah, we did. I don't know why I did that.
That's actually quite pertinent for this for this forum, and since that's nominally what we're attempting to do, and I'm been struggling a bit with how weather ready is defined. So I assume other people are as well, which is good.
That was the point. That is, it's a good nebulous kind of goal that we kind of think, but in order to operationally evaluate how much difference it makes, we need to figure out exactly what it means.
Just a comment that's sort of along the lines that for meteorologists, we don't know what we don't know. The comment about, the different types of social scientists would probably be very useful if one of you in that broad category could sort of define the various sub-disciplines that you think would need to be a part of a team.
Well, and I'll actually offer an opinion from that. That notion from the other group about the Directorate of Human Weather, whatever it was, yeah. I mean, that's essentially a place where there's a large pool of people covering all those disciplines. Because I mean, one of the challenges we've had is that I know some social scientists, but I don't know, I don't know people in all of the disciplines, and I certainly don't know really good people in all of the disciplines. And so that's I think that's a real challenge for us. But I also need to know we need to expand the number of people we're working with them with the assumption that that when we do that, we'll be attracting really good people to what I think are challenging problems.
Our group's term for that approach is the Social Scientists Full Employment Act of 2000.
Could I suggest that people here who consider themselves social scientists get together real briefly and try and put together a couple of slides with some bullet lists of what the capabilities are, what the key interests are, that sort of thing? We could do that. Like right after this meeting, briefly meet to decide when we could meet and do that.
And we'll appoint Robert as the chair of that group to put that together?
I'll do the cat herding, thank you.
Joe Trainer. You don't get away with that.
Actually, while we're doing that, it would be helpful to do that all around, actually, in some ways. Because, like, I know that I learned an awful lot during the service assessment team. Like, hydrologists and meteorologists aren't the same. No. See, none of the other social scientists, no. Got why that's so funny. No, but the point is valid, that there are subdisciplines within as well. So one of the things that having 3 days to sit around and talk about this kind of stuff is we can get to know each other a little bit. And I think the strength for all of this comes from the fact, not that we'll come out of this with consensus, but that we'll at least start to understand how each of us approaches this problem differently and how that brings value added to the total solution rather than a compromised solution.
This may not be the right time for this, but I was discussing just before this session about in that getting to know you dance with these folks in this room, what about breaking the mold, moving these walls away and standing outside in Tuscaloosa tomorrow? It's a 60-minute drive, you know, and a bus to rent, and just go at some of the 15th Street areas and stay there, all of us. You know, we have to understand the holistic nature of the problem that we're facing, and we will get there, but we will get there slowly, without windows and without seeing the reality on the ground.
Next. Okay, I think it's Chris. The orange mishmash. Yeah. That is a dot.
Is it a dot? Okay.
And there's your little computer.
Okay. Well, I think our group was a little bit different from everyone else's. It sounds like a lot of the other groups were really cohesive in terms of content and specialization. Within our group, we actually started interdisciplinary. We had folks that were emergency managers. We had folks that were specializing in disabilities, specializing in aging as well. We had other folks that were very interested in technology. So we also had engineers. So in our little group of 10, I think you're going to get a, oh, not me, okay. We're going to get kind of a foreshadowing of the next round of discussion. As you can see, we were tasked with quite a bit. Everybody else had one white paper to discuss. We actually had 3. So if we look at what we were looking at, we were covering population segments with disabilities specifically. We were looking at pre-event planning for post-event recovery. We were also looking at hazard mitigation, specifically structural solutions associated with safety rooms and shelters. So having said that, having laid out this Herculean task, one of the things we started to discuss was the idea that all of this should really be discussed in the context of social vulnerability. Just to define social vulnerability, what we're talking about here is a multitude of societal factors that might influence who's going to get injured and who's not. So having said that, if you looked at our white paper, specifically we identified different folks who are disabled. One of the issues that we discussed was the idea that a lot of previous research has looked specifically at mobility impaired individuals. One area that's received much less attention is cognitive impairment. What about folks who have different types of disabilities, such as, well, Alzheimer's for older folks, other folks who are younger that we have to consider. So aging in children basically point to a couple different areas within demographics that we should look at from a developmental perspective. As you can imagine, people at these different ends of the spectrum are going to have different disabilities. So we're going to really have to look at that. One thing that Laura and I discovered when we were writing our white paper for disabilities and aging was that a lot of commonalities exist. Low socioeconomic status is something that appears to be common amongst a number of these different areas. So having said that, we actually had Mr. Ortiz back there, who was very loud and telling us about folks who are speaking English as a second language. That's something that we really need to focus on as well. I think Linda said it best when she just mentioned the idea that one size does not fit all. We have to look at these factors. We actually had a discussion about the homeless population as well. And the reason that we have a question mark up there is this idea that homeless people may be better off than the rest of us. We had this discussion that these folks know where to go for shelter. These folks know where to go for help when they're hungry. So when an adverse event like a disaster comes around, these folks are already hooked in to a social network, interestingly enough. One area that we also talked about was the idea of technology adoption. A lot of us are attached to our smartphones. We have internet access and we take that for granted. All these different recommendations that specify fast and quick social media integration, these things really should be discussed, especially for those that may not have that access. So in a nutshell, our group was focused on those without great options. So obviously that encompasses a lot of different people. When we were looking at all these different issues, we were tasked with identifying neglected issues and research needs. One thing that we kept coming back to was the idea that a lot of research out there looks at individual as level of analysis. One thing that we became particularly interested in was when you're thinking about mitigation, when you're thinking about recovery and disabilities, maybe we should look at the community and population-specific factors as a unit of analysis. Rather than individual, look at community, how well the community's doing. And that might be one way to define, are we a ready nation, or weather-ready nation? One way that we could measure that is how fast we recover. So that's one thing we can talk about. Obviously, a lot of communities or different parts of communities are underserved. We need to think about that. We talked about a number of different recovery solutions, a number of different mitigation solutions. As I mentioned, we did spend a lot of time talking about structural solutions such as safe rooms, but we also wanted to think about other communications issues. We wanted to think about different types of coordination. We wanted to think about solutions that were being implemented and those that were not, and why. Specifically, we wanted to identify barriers to implementation. We're going to talk about this a little bit later, specifically with safe rooms, but what types of safety factors are going to be prohibitively expensive? What is going to actually add to this social vulnerability paradigm? Mark's paper back there spoke specifically about these safe rooms costing $8,000 to $12,000 to implement. If we're looking at people with low socioeconomic status, $10,000 might as well be $1 million. So these are the types of barriers we need to understand. When we look at community responses, we have to realize that when it comes to decision making, what types of community responses are going to be chosen? We have to look at decision making from a number of different people in different places. We have to look at folks that are in local government. How are they going about making decisions as that particular type of stakeholder? How are the people that are the users that we've been talking about quite a bit, how are they making decisions? And one thing that we might indicate is we can actually reduce cost. in a number of these different areas by discussing the idea that community responses where we're talking about developing a community shelter, this may be cost effective because it could have other purposes as well. So as we talked about within our group, Elizabeth Davis was telling us about a situation here in Alabama. I think she said it was, what is it at? Senior Centers, Safe Centers. She talked about this idea that one building, if it's reinforced, by day it could be a usual community center, but in the event of an emergency or a disaster, it could be transformed into a shelter that everyone could utilize. So that might be one way of defraying the cost of that type of adoption. Looking at recommendations for future work. We talked about different populations being sensitive to different disasters. Specifically, we talked about hazard types and different segments of the population. We also addressed the issue that was just brought up in the last section, the idea that we should give people options. Typically,